So we left off on example 4. This is everyone's favorite, a missing mass question. This is I was going to say this is about as tough as I'd throw at you. This might be slightly tougher than I'll throw at you, but let's walk through it. It says if M1 has a mass of 8 kilograms and is accelerating upwards, and if mu equals 0.12, and the angle of elevation is 28, find the tension, find M2. Okay, well, Nick, how might I want to start this? Darn right. Nick, what are the forces acting on M1? Get the obvious one. Good. What else? Yep. Is there a normal force? Is it sitting on a surface? No, we're not going to get normal force, Loopy. Then, what are the forces acting on mystery mass 2? Get the obvious one. And now we're going to pause because we're on a ramp. We're going to put the mg on the pointy side of the ramp, and we're going to, m2g, and we're going to break it up into its components. And again, I want to be very careful that I go at right angles to the ramp, and I'll stop right about there. That's going to be m2g perpendicular, and that's going to be m2g parallel.
Good morning again. So, if there
What else, Nick, my friend? Are we sinking into the ground like quicksand? Are we flying to... So we have that normal force. And remember, don't draw the normal force like this. That would be if we were on level ground. The normal force is always at right angles to the surface. So it's going to be... Oh, and it's going to be the same size, I think, as M2G perpendicular. And then friction, which way? Oh, I don't know. Yet I do know, because which way is mass 1 accelerating, Nick? What did the question tell me? So which way is mass 2 accelerating? I got to be fussy. Down the ramp. So if it's sliding down the ramp, which way is friction going to be pointing? Okay. Keegan, what does A want me to find? I can't find tension by going winner minus loser equals M all A, because what happens to the tensions in my big Uber equation every time? What happened to the T's? So I have to look at one mass. Which mass do I know? I'm going to write an equation for that. So you ready? Which way is M1 accelerating? I have to tell you that in the question. If I don't, you can't solve this. Who's winning? Sorry? Mass 1's not a force. Which force is winning? Which way did you just tell me it was accelerating? Who's winning? Yes. Who's losing? Which one? There's several. What's that going to equal? M1A, because we know M1. Okay, so we're going to start out for part A, writing an equation for the mass that we know, like we do for any missing mass question. We ignore the missing mass, we go look at the mass that we do know and find out everything that we can. So tension minus M1G equals M1A. Keegan, how would I get the T by itself? I think just plus the M1G over, right? I don't need to do a swap. The T's going to stay where it is because it doesn't have a negative in front of it or anything like that. So tension is going to be M1G plus M1A. It's going to be 8 times 9.8 plus 8 times 2.1. Keegan, my friend, what do you get? $95.2? You got that already? Or you yeah, you got, okay. Units, Keegan? It's a force. Okay, good. Lena, what does part B want me to find? I know these are your favorite. Here we go. Let's write an equation just for M2. Which way is M2 accelerating? Which way is M1 accelerating? The question told me. So which way is M2 accelerating? I'm going to be fussy. Down the ramp. Because when you say down, I think, no, down the ramp. So which way is the winning direction? Same answer. Down the ramp. Okay, I'm looking at this. Folks, who's winning here? M2G parallel. Who's losing? Up the ramp. And that's going to be M2A. That's the equation just for that mass. So let's write that. It's going to be M2G parallel minus friction equals M2A. I forgot to put tension on here. Read, thank you. Minus tension equals M2A. That's a good thing because I was doing the math in my head and going, wait a minute, all the M2s are canceling. Something's gone wrong here. Okay. Let's do our Trigon substitutions. So 2 lines is, I'm going to do that on the next part here, M2G sine theta minus, and then I would go friction is what times what, and you would say mu times the, and I would say, I don't know the normal force, oh, but look. And you would say, I know another force the same size. It's going to be M2G perpendicular. Which trig function was M2G perpendicular? You do know the answer. Of course you do, right? So it's going to be minus mu M2G cos theta. And read is correct. I can't believe I forgot to put the tension on there. You can see it's easy to make silly mistakes, especially in the morning. And that equals M2A. Lena, what am I trying to find? How many M2s do I have? 3. How many would I prefer? 1. Let's get them to the same side. I think what I would do, because I don't like the tension being negative, I would probably plus that there and minus that there. That's probably the least amount of work. So it's going to be M2G sine theta minus mu M2G cos theta minus M2A. That equals tension. How many M2s do I have? How many do I prefer? You know, it would be really cool. It would be really neat if there was a Math 9 operation that would somehow turn this from 3 M2s into 1. And there is. Do you remember? What is it? Okay, we can factor out a greatest common factor. There's an M2 in all 3 things. By the way, who's in pre-calc this semester? Okay, that's going to be really handy when you're solving log equations. I'll show you that in about a week or so. So it's going to be M2 bracket G sine theta minus mu M2 G cos. Why M2, Mr. Dewick? Why did I put that in? Minus mu G cos theta minus A. That equals tension. How would I get the M2 by itself? What's the bracket doing to the M2? So, yep. Final answer. M2 is going to be tension over G sine theta minus mu G cos theta minus A. Kind of running out of room here. What was tension? 95.2 on the FM dial. G, 9.8. Sine, what was theta? They told me 28 degrees. Minus 0.12 times 9.8 cos 28 degrees. Minus, and what was the acceleration, Mr. Dewick? 2.1. This whole thing is on the bottom of the fraction. Whew! I can do this. Yeah, I doubt I'd give you one this tough. It's just so much work. There probably will be a missing mass question, but it'll probably be a missing mass without an angle. Probably just an Atwood machine. I typed that in right, Mr. Dewick? Looks like it, I think. Did you get, is it 65.1 kilograms? Okay.